Now, I'll provide 8 inconvenient questions for people who use the radiative model to explain how their model is the right one. The first question is, why is the Earth's average temperature highest in July when the Earth is farthest from the Sun and coldest in January when the Earth is closest to the Sun? The difference is about 3 million miles and 3 degrees Celsius. A radiative model can't explain this, but a thermal model can, because the northern hemisphere has far more land to retain heat, while the southern hemisphere has far more water, which absorbs heat and sends it directly to the South Pole. Land has a much larger influence on surface temperatures than oceans do. Next question. Could something else be causing the warmer of the last few decades? Doubling CO2 would have a tiny effect on temperature, if any, but that's not true for clouds. Even a 1% reduction of cloud cover would have a significant effect on temperature. More clouds increase reflection and reduce temperatures. Fewer clouds mean more direct sunlight hits the Earth, creating higher temperatures. Over the past 20 years, clouds have decreased, so more energy has entered the system, and we see a corresponding amount of energy leaving out to space, which shows that heat isn't being more trapped than it was before. There's just more energy coming in from the sun. So the question is, what could possibly explain more heat escaping to space? The radiative model predicts that outgoing long-wave radiation will remain the same as heat builds up in the climate system because the sun doesn't change, but CO2 is increasing. But the thermal model accurately predicts more heat escaping to space as more heat enters, though with various time lags for heat transport. Question 4. What caused the spike in temperature in 2023 and 2024? Was there a rush of increased CO2? Or was it several factors working together? Decreased albedo, the positive phase of the Atlantic multi-decadal oscillation, a couple El Niños, the peak of solar cycle 25, a change in ship fuel type, and a huge underwater volcano eruption. The volcano added 140 megatons of water vapor to the stratosphere. It increased the greenhouse effect in the stratosphere, because even though the stratosphere is very cold, all that vapor can still re-radiate outgoing photons back down toward the surface. The extra water vapor caused a lot of surface warming, but it will dissipate over the next 5 to 10 years. It may be radiative, but it certainly isn't man-made, and it isn't climate. Question 5. What is heating the oceans? The Argo floats started measuring the mid-level ocean temperatures 1,800 meters under the surface in 2004, and the result is about 0.04 degrees per decade in less than 2 decades. Back radiation from CO2 can't warm the oceans. In fact, if anything, downwelling infrared radiation actually cools the oceans a bit through evaporation. The only thing that explains this rise in ocean heat is more direct sunlight penetrating the water. Fewer clouds, not more CO2. Fewer clouds, not more CO2 would do that. 6. Why isn't Antarctica heating? Antarctica is the driest place on Earth. Water vapor there does not change. CO2 has risen there, the same as everywhere else on Earth. You can see it in the background here, yet temperatures on the Antarctic plateau are not moving with CO2. At this altitude, even though it's very dry, water vapor is still responsible for more of the greenhouse gas effect than CO2 is, probably around 2 to 1. But water vapor doesn't change while CO2 does. So the principal researcher of this paper and this data sent me this note. I cannot find any warming associated with the increase in greenhouse gas, but I found that warm air intrusion into the interior Antarctica is increasing during the past 30 years. Now that, of course, would coincide with the decrease in albedo, which has increased the amount of sunshine reaching the surface. So the Antarctic is one place where the greenhouse effect has not increased despite an increase in CO2. and this is the thermal model at work. This is the South Pole Station where the researchers live. They recorded their lowest ever surface temperature in 2021. No hockey stick shape here. This year, Antarctica had a sudden stratospheric warming event. The last one was in 2002, but those events have been happening for millions of years. They're rare, but like their more common counterparts in the Arctic, they're part of the natural cycle moving heat to the poles. That's because CO2 doesn't cause any warming at the poles. The same is true in the tropics. Here's the question, where are the hockey sticks? Why aren't temperatures increasing in the tropics? There's even more radiation there, so there should be plenty of global warming in the tropics. Well, here's Pamban, India. From a thermal point of view, stable tropical temperatures make sense. If albedo's going down, you'd expect a slight rise over the last 20 years or so. And that's exactly what we see, a very slight rise in temperature. Here's Papua New Guinea. From a radiative point of view, we should see a hockey stick shape here, but the tropics are insensitive to changes in CO2. Seychelles, Mahi Island, has data since 1890, and look, you can see about a 1-degree rise since 1980. And that's from a remote weather station that they moved to the airport when they built the airport in 1972, so the weather people could more easily record temperatures near their offices. So the story here is of stable temperatures followed by the growth of their tourism industry. Here's a hockey stick shape showing sea level rise in American Samoa, where the UN Secretary General Antonio Guterres made a trip in August 2024, and he made a video saying sea level is rising fast. He went to American Samoa specifically because there was an earthquake in 2009, and since then, the island has been sinking at a rate of 6 inches every 10 years. And during his junket, Guterres pronounced, "This problem that we see in Samoa will not stay in Samoa. It will be happening more and more everywhere in all coastal areas." So according to him, CO2 is going to cause earthquakes and land sinking in all coastal areas. If you only have the radiative model, then it looks like CO2 drives our climate. So here's a question. If water vapor is the main greenhouse gas, why aren't there billions of dollars available for entrepreneurs to suck water out of the atmosphere? Well, the answer is that it's not about climate. It never was. I'm going to leave the questions here, but there are many more on my website. In the next video, we'll look at future temperatures.